Hey everyone. Like I said on the previous page or in the first lesson, I have my Pythagorean identities. Let me prove each of them, or not prove, let me derive them. Where do they come from? Okay, so in case you're ever stuck, you're like, oh, I can't remember that. They're also on your formula sheet, but still, it's always nice to know where they come from. Let's recall this. Well, let's start from the basic. You remember this, a squared plus b squared equals c squared. That's the Pythagorean theorem. Well, we use a version of that for a unit circle. And this is the equation of a circle, right? Specifically a unit circle, x squared plus y squared equals 1 squared. This is also thinking of it as radius squared, but we say 1 squared or just 1. Okay, and then we can also make this substitution where x is equal to cosine of theta and y is equal to sine of theta. So our very first Pythagorean identity becomes cosine squared of x plus sine squared of x equals 1. And remember, I'll just put this off to the side. Cosine squared of x is equal to this. And we just do that as a different way of notation. Okay? Sine squared of x is equal to sine of x squared. Okay, two Pythagorean. So number one, we get two different versions of this by subtracting sine squared of x from both sides. So I get cosine squared of x equals 1 minus sine squared of x. The other version I get is if I subtract cosine squared of x from both sides. So I have sine squared of x equals 1 minus cosine squared of x. So that's our first Pythagorean identity. Number two, if I take cosine squared of x plus sine squared of x equals 1, let me divide both sides by cosine squared of x. What happens? This is 1 plus, well, sine over cosine is tangent of x. Well, when I square it, that's tangent squared of x. 1 over cosine squared of x. Well, let's think about what that is. That's a reciprocal trig identity. So what happens when I take the reciprocal of 1 over cosine squared of x? Well, that is just the secant squared of x. Okay, so here's our first major one. Here's our second one. A lot of times on a formula sheet, why we leave it like this is because it's unchanged from the first form, right? 1 plus tangent squared of x equals secant squared of x, and now you see where it comes from. Well, we've seen other versions of this. If I subtract tangent squared of x from both sides, I have secant squared of x minus tangent squared of x equals 1. That's one version. The other version I've seen is if I subtract secant, what am I doing here? I subtract, what's another version here? Well, you can rearrange it where I have the 1 on one side. The other way you can think about it is if I subtract 1 from both sides, so tangent squared of x equals secant squared of x minus 1. So that's another version. Okay, and then you can think of a third version where we isolate, we have the three versions, right? Okay, number 3. if I start with my first Pythagorean identity, cosine squared of x plus sine squared of x equals 1, let me divide everything by sine squared of x. And where does that get us? That's going to get us our other Pythagorean identity, our third one. This is cotangent squared of x. This is 1, and that is cosecant squared of x. That's our third one. Versions of this, right? I'm going to, let's see, let me subtract cotangent squared of x from both sides. So I get, well, that looks like a pi. Let me just make that look like an x. Okay, so if I subtract cotangent squared of x from both sides, I get cosecant squared of x minus cotangent squared of x equals 1. Another version, if I subtract 1 from both sides, I have cotangent squared of x equals cosecant squared of x minus 1. So those are my 3 versions of the Pythagorean triplets. Sorry, the 3 versions of Pythagorean identities.